Even though I am a kind of navigated speaker, this is my very first time in English, so please forgive me if I'm going to make some mistakes. But yeah, I think we can start, but I still don't see the... okay, here we go. There we go. So yeah, as Susanna already introduced, spoiled, we are actually going to talk a bit about server-side rendering in PHP. This is an introduction because, of course, we cannot cover everything in just 40 minutes. But yeah, at least, let's say, I would like to give you some tools so that you can get started with server-side rendering in PHP. Before we delve into the topic, just I mean, to break the ice, how many of you have already gained experience with server-side rendering, regardless of the language? Okay, not bad, not bad. Okay. Ego slide, just to introduce a bit also the company I work for. I joined Redokun a few months ago. I'm technical team leader of product team. Redokun is a translation management system, collaborative translation management system, which basically allows to collaboratively work on the translation of the documents in a few minutes. As I already said, I'm also the author of Live Through Mistakes, which is my newsletter. Here you can find, you can also find a QR code if you want to get in touch with me, or since we will, there will be an example during the talk. If you want to see the code, if you want to test it on your local environment and so on, you can just scan the code, scroll down to the page, and you will find the GitHub repository. Enjoy it. So let's start. I would like to give you a bit of introduction, a bit of context of where I gained this experience with server-side rendering in PHP. As I mentioned, I joined Redokun just a few months ago, so I actually gained my experience in my former company. It was a podcasting company, so in the media industry, we needed to revamp our listening platform because it was actually built on top of a 15 years old monolith, hard to maintain, hard to evolve, impossible to have any kind of experience for the users. I don't know if this sounds familiar, but I see some facing here. So yeah, at a certain point, we decided basically to move towards another direction. And that's where I gained this experience. We have some constraints. For example, millions of pages already indexed on search engines. So SEO performances were pretty important for us. We didn't want to lose that kind of indexing. We also were lucky because we already had a CMS for our customers, and we had a robust set of APIs, so we could rely on them. And other constraints was PHP-centric team. The team was mainly skilled on PHP, so from zero to little experience in JavaScript to do that, and also short time to market, because we wanted to present the new product in one of the most important events of the industry. So, given those boundaries, the final solution was what it is called a backend for front-end. So a backend application built consuming another backend for the APIs, server-side rendering approach, as mentioned, to preserve the SEO performances, but this is another of the features, let's say, of server-side rendering. This allowed us, anyway, to keep a single-page application-like experience for our users to improve the experience, the interaction with the website. Everything built on top of serverless architecture on AWS, so leveraging the powerful tools such as CloudFront, Lambda, Breath for working with Lambda, and so on. So this is the context in which I gained this experience in the last more or less 1.5 years, couple of years. But yeah, let's start by talking about what server-side rendering is, because we talked about it, but we didn't introduce it. We can consider server-side rendering like a combination of the old-fashioned way of building application, which is called multi-page applications. If you started working on web a few years ago, if you are vintage, let's say, like me, you probably for sure have worked with multi-page applications, which are the main characteristics that there is a request, the server, the response coming from the server actually contains the whole HTML file, and the page is already ready. On the other side, in the last decade, probably, the single-page applications are more famous, let's say, and single-page application instead, you have a full interaction of the user without any full reload of the page at every request, but there are more requests because you have to first download the JavaScript needed to make extra API calls to fetch the data and then rendering the page on the client side. Server-side rendering actually, let's say, takes the best features from both and combine them into a single approach. So in short, server-side rendering is simplifying, of course, and removing any caching layer from this topic, just to simplifying the topic itself. Server-side rendering is actually, there's a request coming from the client, the browser, whatever, and the first response is actually the HTML of the page. So the page is already rendered, even though we don't have yet the single-page application-like experience. But just right after the rendering of the page, you can start downloading and enabling the JavaScript side, which allows users to interact with the page without the fully reload. And this is more or less what server-side rendering is, simplifying, but yeah, this is the main feature of server-side rendering. But yeah, this is the main, this is just shows how server-side rendering versus client-side rendering works. We have a fully, we have a fully working page at the very first request, while on the client side, you have to render, download the JavaScript, then render the first part of the page, making additional API requests, and then you have the full page rendered and interactive. But yeah, one of the questions might be, okay, but we have plenty of libraries on the JavaScript ecosystem, so why should we do that in PHP? Well, I can give my experience, and yeah, one of the reasons is just to reduce JavaScript usage, and I don't want to, let's say, start any flame about JavaScript, not at all, but unless you have a Node.js application or you are running on a JavaScript backend, actually, if you already have a PHP application, you don't want to migrate to another language and writing everything from scratch. Maybe you want to actually, let's say, start migrating your own application and keep it evolving rather than restarting from scratch. So in this way, you can still rely on PHP for your day-to-day work and just rely on JavaScript for what it is actually made for the interactions. And we will see during this talk that actually we are going to write we're going to write 0 lines of JavaScript to make it works. It doesn't mean that you don't need JavaScript for most complex things, but still, the amount of JavaScript required with server-side rendering in PHP is very little. Then another important thing is that this way you have the state centralized, because if you have ever worked with a single-page application, you have the front end, you have the back end, and you have the same state shared across the two environments, and it can lead to inconsistent data, overhead, and so on. This way, you have the state in a single place, and it's easier to deal with it. More, a single stack. So instead of have 2 different code bases, instead of 2 different languages with their own libraries to keep data, to maintain, and so on, you have a single code base, which is easier with this approach. And last but not least, even though I have already told it, you don't have to rewrite everything from scratch, because if you want to start integrating server-side rendering in your PHP application, you can do it instead of rewriting everything from scratch. You can just start adding new components, new pages, but we will see this in a while. So we talked about server-side rendering. We said why we would like to do it in PHP, but what does the PHP ecosystem offers for doing so? Well, at this moment we have two main libraries, one for each of the most used frameworks in PHP. We have Livewire for Laravel, which is actually a full stack framework. So it means that you install it and you are ready to go. And it leverages the power of Alpine for the JavaScript interaction. And yeah, once you have installed Livewire, you can start using it in your Laravel application. On the other side, if you used to work, if you are used to working with Symfony, we have Symfony UX, which is not a proper framework or a proper library, but it is considered more a set of tools and conventions. But the final result is pretty much the same, because leveraging Stimulus and Turbo.js for interaction and navigation, and using and extending Twig to, let's say, allow it to work with components, you can actually use it on your Symfony application. Another important thing, because we delve into the topic, there is also a pattern we can follow if we want to start working with server-side rendering. If you already have experience with any JavaScript library, React, Vue.js, well, you have already seen this component-based architecture is just a set of rules you can adhere to actually have a maintainable and extendable server-side rendering application. Here you can find a link to the Symfony UX documentation, in which those rules are pretty well explained. The examples are, of course, for Symfony, but the theory behind the rules is pretty much the same also for Laravel. So if you are interested to the theory, you can rely to this link in any case. But let's see which are these rules. First one is composition, is the most important one, is the game changer here, because you should start thinking about a page like a collection of small and reusable components rather just the whole page. As you can see from this example, I try to reproduce in PHP the Redokun application, and I will talk about this in a few minutes. But here you can see there are a set of components. We have a main component, which is the document. Then we have a component for the title, for the table, which contains the languages in which the document has been translated, and so on. So starting from the bigger picture, you can start splitting the page into small and reusable components. Then we have independence, which means that the component lives in its own context. And so it is not aware of everything else happens inside the page. Then we have props, the properties. Even though we said that the component must be independent, this doesn't mean that we cannot actually customize it. So we can change the properties, we can change how it renders according to those properties. And this is what properties are. So in this case, for example, we have a translation component, which is this row here. And according to the properties we are injecting, different languages, different status, the rendering is pretty much different. And then we have state. The state is just like a property, but with an important difference that the state, this special property can change its value during the life cycle of the component. And this is what actually enables, let's say, the interaction in our pages, because in this example, we have the confirm button that once you clicked on the button, you actually change the status of the whole component. even though we said that the properties, so the components are independent, we can see that there's a way to make them, to let them communicate with other components. But still, we can change the state of a component, of some of the properties inside a component, and the user can interact with them. These are the rules of the component-based architecture. So now, since we already have the whole context and we know what we have in our toolbox, let's say in PHP, let's see how we can actually build our server-side rendering application with both Laravel, Livewire, and Symfony UX. This is the final result. This is the same QR code I have already mentioned a few minutes ago. Still, if you want to go there, just you can download and test the application. It's a simplified version, of course, API are mocked and so on, but at least you can focus on important things. How it works, as mentioned, we are a translation management system, so we have a list of documents. You can click on the details of each document, and you can see the list of languages in which that document has been translated. You can interact with the language because you can confirm the document to say, hey, it is already translated, and you have a download to start the download of that document in that specific language. This is what we are going to reproduce with server-side rendering. But yeah, let's start with installation. How can we install the libraries on our application? Pretty straightforward on Livewire, compose and install Livewire, and you are done. On Symfony UX, as mentioned, it's a set of libraries and tools. So we need to install all of them. We need to extend We need to extend Twig with the Twig component. Then we have to install Asset Mapper to, let's say, handle the JavaScript libraries and to load them into the page. And then you need the Stimulus and UX Turbo for the JavaScript side for the interactions. And that's it, nothing more to do. Then, once you have installed it, you have also to include in your templates. On Livewire, the only thing you have to do is just include the $slot variable in the portion of the page in which you want to add the new components, so the interactive part of your website. On Symfony, you don't have to do anything because it already relies on the block approach that we already have on Symfony. And that's it. Then you have to create routing, to customize the routing according to your new pages or your components. On Livewire, on Laravel, the only thing you have to do is just replace the traditional controllers from Laravel with the new components from Livewire. And that's it. All the other rules are preserved and nothing is changed. On Symfony side, nothing you don't have to do anything because it still relies on the traditional routing system, so no changes yet, just relying on what you already have. And now it's time to start creating our components. We talked a lot about components, but what are we talking about? What is a component? A component can be considered, simplifying, just like a PHP class that inject properties to a template. And if you have worked with the MVC pattern, is something similar. The only difference is that it is true for each small component instead of the whole page. And that's it. In this case, for example, for Livewire, we create this is not Livewire actually, but this is Laravel because this is a static component. We will see what is the difference between static and live components in a while. But still, you can just create the component injecting the properties that you want to customize for that specific component and just render it with Blade in this case. To render the component, you just have to use the X dash at the beginning and of the HTML tag, and then you have common, in this case, is the name of the folder in which the template is contained, and then status, which is the name of the template. And then you can just pass the properties to the component. This is how it is rendered. It is, this status component is actually the confirmed label you have in the line of the translation. And the same goes for Symfony UX. you have to register the component as Twig component so that it is enabled on Symfony. You can just pass the public properties and then use Twig to render the component. And same, you can recall it in your templates just using Twig column, the name of the folder in which it is contained, and the name of the component, and then the properties. That's it. There is a specific type of component which is called anonymous component. The anonymous component is a component without any PHP logic. For example, you didn't make any API request or you didn't fetch any data, you don't need to fetch any data from the repository or stuff like that. Just like in the example we have already seen, well, you don't need the PHP class. You can just rely on the template. And this code is actually the same used in the slides, in the previous slides. You can just get rid of the PHP class and it still works because there is no logic inside the PHP class. Okay, so we introduced the components, but we talked a lot about single page-like experience. So how we can enable users to interact with our page while preserving the SIO performance in this case. So by having, at the very first request, the full page already reloaded. How can we do so? Let's say which are the types of interactions you might have on a page. Even here, simplifying, you can have a state change. You have the navigation, so the user clicks on another page and you have to refresh the portion of the page in which the page is loaded. Or you have the forms, for example. Let's see how we can enable it in both Livewire and Laravel. Let's start with state change. On Livewire, but also on Symfony, we have to introduce the concept of live components. Live components are usual components. The main difference that they allow to enable interaction. So you can change the state of their own properties during the life cycle of the component. How can we do so? In Livewire, instead of having a Laravel component, you can rely on Livewire components. So you extend a Livewire component, you have the mount method, which is called every time the component is mounted inside the page, and you can inject the properties with their initial state. And then, well, I omitted the render part, but it's just telling it the initial state, so the template and the initial state of the component. And then you have another method. In this case, it is called download, because what we want to do is actually what we see in that animation. So clicking on the download, we will do something, I don't know, an API call or generating the PDF document or whatever else. We don't care for this example, but at least we want to give the user a feedback. So a piece of we want to give feedback to the user. So in this case, at least changing the label. How can we do so? I said a download method, download because it's an arbitrary name, so you can call it whatever you want. And besides of the magic you can do to actually start the download, you are going to change the value of the state. In this case, the downloaded property is false at the beginning, and it becomes true once you clicked on the download. And as you can see on the other side, on the template, there is actually a wire click attribute in the button with the name of the method. And just with this single attribute, you have enabled the interaction. You don't have to do anything else. It's Livewire, thanks to Alpine.js and thanks to its own code that runs everything under the hood. And how it works under the hood? Well, as you can see from here, every single mounted component, every single live component has its own status, its own state with its own properties. And whenever you click, you interact with the page, there's an API call to the method, in this case the download, and the API call returns the new state and the new HTML, so that you don't have to render the HTML on client side, but you can do it on just replacing it. And it's pretty much the same on the Symfony side. You have to convert it from a strict component to a live component. You have to explicitly declare which are the live properties, the ones that are allowed to change their own state during the life cycle. And you have to register any method inside your component with the live action attribute. This way, we are exposing this method to the front end so that we know that it can be called. And on the other side, on the template, you have a data action attribute. This is a constant, actually, to enable it, live action. And then you can inject another parameter, data live action parameter, that contains the name of the method. And that's it, nothing different. I forgot to mention something, sorry, on Livewire. I just realized that the only change you have to do on your templates is how you render the component, because instead of having X document, whatever, as Laravel component, for the Livewire components, you have to prepend it with the Livewire one. Sorry, I forgot to mention this. But apart from this small difference, everything is pretty much the same. Nothing changes on Symfony side instead. How it works under the hood, same things already mentioned for Laravel. There's a state inside the component, inside the HTML tag in the HTML, and whenever the user interacts with the page, there's an asynchronous call, and both the state and the HTML is rendered. This happens thanks to what is called morphism. Morphism is actually a way to, let's say, simplifying a lot, to make a diff of at runtime of the differences of the page, so that you can render only the portion of the page that is affected by the interaction. Well, there's another thing. So far, we have just seen the change of the status of a single component, which is independent. It doesn't interact with the components before, sorry, with the parent's component. But what if we want to change the state of the parent component according to the interaction of a user? As in this case, clicking on the confirm button, you can actually confirm the translation on the backend, and then we want to see the new state for the whole component. Well, in this way, we can rely on events. And instead of putting the logic inside the very last component, you can actually dispatch an event and delegating the business logic to the main component. How can we do so? On Livewire, you just have to dispatch. You have a confirm method. You can just dispatch the event, and that's it. On the other side, on the translation, so the main component, the parent component, you can actually use the on attribute as a listener to the translation confirmed event, and in this way we can also customize the suffix, so we can be specific with the ID of the resource if needed, so that you don't have to check if I have to listen to this specific event for this specific resource or not. And that's it. In this case, we are just making an API request to the backend and just changing the state of the translation property inside the component. There's an important thing to keep in mind. Whenever there's a state change of a parent component, it is not automatically reflected on its own children. So you have to explicitly enable it, and it works for both Laravel and Symfony. You have to explicitly tell on the template that you want also to update the state, to re-render, actually, to re-render the template also of the children components. In the example, if you download the example, you will see that there is another attribute for both Livewire and Symfony. How about Symfony? Nothing different, though. You don't even need the method on the child component. You simply have to have a data action which is called live emit up, which means that all the parent components can listen to that event, and then which is the name of the event. And on the other side, on your own translation component, you can have the live listener attribute, which enables the listener, and you can do the same API request. And that's it. We enabled interaction. We allowed components to interact with the parents component without any JavaScript line of code. What about navigation instead? Because we talked about the interaction between the interaction of the user with buttons and stuff like that. But what about navigation? Because if you work with single page applications, you see that clicking on a new link, you don't have to fully reload the page. You can do the same also with server-side rendering, and you can do the same with PHP. And it's pretty straightforward. We have to do just a very small change on Laravel side, on Livewire side, because the only thing we have to do is enabling the wire navigate attribute to our links, which means that unless you explicitly want to fully reload the page, for this specific, with the wire navigate attribute, you enable the asynchronous loading of the page, and then it will be run. Only the portion of the page affected by the navigation will be updated automatically. And that's it. And the same is for Symfony. The only difference is that basically once you have installed Turbo.js and you have enabled it in your Laravel, Symfony application, there's nothing else to do. It is automatically enabled, and all of your links are automatically converted to single-page-like experience, let's say. What about forms instead? Because in probably the 99% of the project I have worked in my career, I had to deal with forms. Same thing as before. Both Livewire and Symfony provide us with a set of features that simplify the interaction also on the forms. On the Livewire side, you can create your form component. You can declare which are the properties, the actual input HTML elements you want to have in your form. You can actually add a validation. In this case, there's only the required attribute, but you can do plenty of things with it. And exposing a save, in this case, method, which validates the form and then do the business logic. So in this case, creating a post. On the other side, you have your form. In the form, you can bind your input elements with wire model attributes. So in this case, the first type text wire model title is actually binding the input to the public title property. And at the form level, you simply need to add the wire submit attribute, telling which is the name of the method you have to call to execute whenever the user submits the form. And that's it. You actually can have your business logic outside of the component. This is just a simplified version, but still, you can make the users interact with the page without and having a single page-like experience without writing any line of JavaScript. Again, for Symfony, it is even easier because you can rely on your already existing Symfony forms. You don't have to make any change also on there. The only difference is you have to pay attention to the status code that is returned, because Turbo.js automatically replaces the submission of the form with an asynchronous submission, but it relies on the status code to understand if there is a success or an error. And so the only thing you have to do is just change the status 200 in case of success, 422 in case of error to the response, and that's it. Your forms are automatically converted to a single page-like experience. I don't know why, but I like this word. I'm reusing it a lot of times during the talk. And this is basically it. This is the final result. This is the same we have already seen. So everything as done with just templating and PHP code, and to be honest, with a bit of ChatGPT, because I don't know how to use Tailwind, so for the CSS part, I needed some help from ChatGPT, and it is good at it, actually. But see, this is what I have done. One important thing, we have a lot of interaction, so how about testing? Testing is the thing, in my opinion. So you have to test your code, you have to test your application, but there's a lot of interaction. What can we do about it? Luckily, both Livewire and Symfony allows us to test our application. There are a set of tools for Laravel, there are a set of tools for Symfony that basically allow us to test our application at every level, from the functional tests, so that you can actually test the whole interaction, to the single components. So you can test how the state change, you can test how the application behaves according to the interaction, and so on. On the Laravel, on Livewire side, you simply have to rely on the test library coming from Livewire, and there are a set of assertions and a set of method for example, the call or the dispatching of an event and so on to reproduce it. Same is for Symfony, because using the interacts with live components trait, you can actually have a set of methods that allows you to interact with at every level. Actually, this is a component level, but Symfony also have Panther. I don't know if you have ever heard about it. Panther is another library to test end-to-end applications, so this is yet another level of testing that you can rely on. And we might say that this is it. I just want to spend a couple of words more about something that can be very helpful for us on our day-to-day work. And I want to start from Vault on Livewire, because if you start getting familiar with Livewire and you like the React approach, in which the state of the component is inside the same file is in the same file alongside the HTML, and you want to reproduce the same approach, you can rely on Vault. It is already installed, and it basically enables you to have the state inside the Blade template. Everything is centralized in a single place. The only suggestion is to start getting familiar with Livewire first, so that you correctly understood how it works before, because the debugging is a little more complicated, at least in my experience. I don't know if it's the same for everyone else, but still, I found it a little bit complicated to debug, the debugging phase. But apart from this, it is very powerful. On Symfony UX instead, I didn't mention yet, but it is very important to get to know. Symfony UX comes with pre-built live components, which means that there are a set of libraries ready for enabling dynamic and reactive UIs inside your application without writing JavaScript. For example, you can render the maps in your application. You can have the autocomplete, or you can have you can build the charts using chart.js and so on. There are a quite huge number of libraries, and I will suggest you to give it a look. Still, we didn't talk about interaction with JavaScript libraries, because even though we don't want to, well, that's not even true, even though we wouldn't rely a lot on JavaScript while building a PHP application, at a certain time, we might need to work with it. Well, both ecosystems offers different set of tools to do so. So if you want to include, in the case of Symfony, for example, if you want to include your JavaScript library, React, Vue, Svelte, and so on, you can actually rely on some components already existing that allows you to include your code inside your PHP application. And there's something new on Livewire, which is Inertia. Inertia has been released a few months ago, if I'm not mistaken, probably on December of the last year. But this is actually, let's say, a library that allows you to build your application using JavaScript frontend, but still relying on backend routing. So instead of delegating the routing to the frontend, like you used to do probably with React or any JavaScript library, you can still have all the routing on Laravel, while your application can be built on your JavaScript library. And that's basically it. To wrap everything up, there are just a few key takeaways I would like to leave you before the end of this talk. I didn't mention so far, but since at the beginning I introduced the project in which I worked on with server-side rendering, at the end we opted for Laravel, and this because the context mattered a lot, because Tailwind, native support to Tailwind on Livewire, because the team already had experience with Laravel, and the curve level was easier, of course, for them, so we wanted to go in that direction. And another thing that I didn't mention here, but it is worth mentioning, is that since we built it on top of serverless architecture, Laravel already comes with Octane. Octane is, let's say, simplifying, a way to run your application instead reducing the I/O of your application. You can just actually run your application from the memory. So this is very good fit with the serverless approach, so that you don't have the I/O which is slow, especially on that specific context. And so we wanted to go in that direction. Of course, it wasn't all smooth. We faced several challenges. Performance at first, overweight states, because we started exposing everything inside the states, but we had to deal with, for example, with the Lambda payloads, because Lambda payloads cannot be higher than 6 megabytes. And since Laravel renders all the HTML in the response of the API requests of the interaction, huge state means huge HTML, so we had to deal with it, for example. We also had to deal with shared sessions, because we wanted to allow the coexistence of both the legacy and the new application during the migration, and this was a little bit tricky because of the serverless status of the new application, and because of memory leaks, because having the PHP application running, everything running totally in memory means that you have to pay attention to memory leaks, because you have to reset the states of every middleware is used during every PHP request, because the connection is not closed at the end of a single request, but the connection keeps open and it is shared across multiple requests. Another couple of takeaways, and are from my personal experience and not that experience. It is server-side rendering. I have already said this, but it's not just for greenfield projects. You don't have to rebuild everything from scratch. You can start migrating your application to a server-side rendering approach step by step, converting the pages, enabling the navigation, and so on. You don't have to stop your team from working on your application and writing everything from scratch. You can just keep it evolving. Last but not least, server-side rendering is not a one-size-fits-all solution. It works well when you have to deal with, for example, SIO performances, when you want the whole page rendered at the beginning. It works when you don't have a lot of interaction, but still, single page applications are the solution when, for example, you have applications that are more interactive, that have a complex, let's say, interactivity from on the user side. And that's it on my side. Before leaving you, I just want to remember to rate the talk. It is important for both the groups. It is important for me also to understand if I'm going in the right direction. And thank you very much for your attention.